Welcome
Welcome
to listen.
to listen 5.2 Intercept.
Right, today we're going to talk about how to identify the different intercepts. We're going to talk about x-intercepts and y-intercepts. Right, so first of all, when we look at this problem here, you really have to focus on what the problem is telling you. So we have miners who are exploring 90 feet underground. Right, so 90 feet underground is important because it's telling you that that's negative. So we know that our graph is actually going to be going down. And we're going to be in the fourth quadrant, okay? And then now they ascend, so they go up in an elevator at a constant rate. So since it's a constant rate, you know that that means that it's going to be a straight line over a period of 3 minutes. Right, until they reach the surface. In this case, the surface is an important number because we know the surface for elevation is going to be 0. Okay, so in the coordinate grid, our horizontal axis, our x-axis, is time, and our y-axis is elevation. Now, typically we're used to our graph going up, so going this way, but this time it's going down because they're going underground. So you really have to kind of change the way you're thinking about it, and remember that if you extend these, that this is quadrant number 4. So you're,
I want to do with you.
So it's not that you're going, up and into here, you're going down.
Down?
Yes, we're going down.
Why are we going down?
Because the miners are going below the surface.
Okay.
All right.
Also.
All right, so here we go. So now the first question is, what point represents the miner's elevation at the beginning of the ascent? So when they start, so when you look at this, it tells you that they start 90 feet underground. So that point on the graph would be that at 0 minutes, they're at negative 90 feet for elevation. So that point would be 0, negative 90. Okay, so then the next, what point represents the miner's elevation at the end of the ascent? Stop repeating me. So at the end, so when they're done. So here, we don't have a line to look at this and figure it out, but we can figure it out from the problem. We know that it takes them 3 minutes to get to the surface being 0. So at 3 minutes, so here, let me plot our first point. So then at 3 minutes, they are at a 0 elevation. So over 3 and up 0. So that point would be 3, 0. And then now I know that I can actually draw a line between the 2 points that will show the, there we go, the speed of their ascent. Now, I can't let it go through the dot, okay? I can't let it go through that point because of the fact that they started at negative 90 feet, okay? And I can't let it go past the 0 because of the fact that they ended at the surface. Okay, so in this case, my line doesn't go on forever. It starts and it stops. So it's a line segment, not a line.
Look, Mommy. That's trying to come out.
Okay. So now we want to know, what is the point where the graph crosses the y-axis? So remember, the y-axis is the one that goes up and down. It's the vertical axis. And the point where it crosses is 0, 90. And then where it crosses the x-axis, our horizontal axis, is 3, 0.
3, 0?
3, 0, that's right.
Why is it 3, 0?
Okay, so the point where the graph intersects the y-axis represents the beginning of the miner's ascent. Will the point where a graph intersects the y-axis always be the lowest point on a linear graph? So I want you to think about this. In terms of when you graph things, is the y-intercept always the lowest point on the graph? The answer in this case is no. So we could have a y-intercept that's all the way up here, and then all of a sudden our graph goes down this way. The y-intercept is not always the lowest point in the graph. It just happens to be for this one. Okay, so now the y and the x intercepts, I'm just going to kind of go a little bit off the book here. Intercepts are, so think of the word, so where it intercepts the line. So think of like football when you have an interception. The player has to come across the passing route and connect with the ball. So in this case, this is where our graph comes across and steals the ball from the receiver. Okay, that's kind of the best way that I can put it in sports terms. But in this case, you're really just looking for where does your graph cross the y-axis, and that point is going to be your y-intercept. And where does it cross the x-axis, and that's your x-intercept. Now, you're going to notice something here. We have 0, -90 for the y, and 3, 0 for the x-intercept. So every time you have an intercept, one of your values is going to be 0. So when it's the y-intercept, you're not moving on the x-axis. So for the y-intercept, your x is always 0. And then you're going to have a number for your y because you're moving up and down. For your x-axis, your y is going to be 0 because you're not going to move up and down, but you are going to move left and right. All right, so here we go. So knowing that, we know that if we actually go through, so here we have an equation and it's in standard form. Even though it's subtraction instead of addition, remember you can change this to plus a -2y. But to solve for the x-intercept, like I told you, we have a value for x, but we know that y has to be 0. So if we just want to take our equation and solve, what we can do is we can replace y with 0 and then solve for x. So in this case, when we do that, we get 2 times 0 is 0. And then we get 3x is equal to 6. We divide both sides by 3, so we find out that x is equal to 2. So then in that case, we know that our x-intercept, so where the graph would cross the x-axis, would be 2, 0. And then it's the same for the y-intercept, except for now you're going to replace x with 0 because you want to know what y is when x is 0. Again, look at your point. This is what y is, so y was -90 when x was 0. And then when you do that and you go through and solve, you get that when x is 0, that y is -3. So let's go ahead and try this. So if we are going to solve for x, we're going to replace the y with 0. And when we do that, anywhere in the equation where we see y, we replace it with 0. So now we have 6 times 0 plus our -5x. So we're left with -5x is equal to 60. We divide both sides by -5 and we get -12. So the x-intercept in this case is -12, 0. Now, you could also say that the x-intercept is just -12. Typically, when they ask you for the x-intercept, you want to say -12, 0. You want to give the point. However, when we're talking about putting it into slope-intercept form, when we talk about putting things into slope-intercept form, you're going to need to understand that y-intercept is just the number from the ordered pair. Stop it. I'm not kidding. All right, so here we go. So to find the y-intercept, replace x this time with 0, and then we're going to solve for y. So we replace x with 0, so we do -5 times 0, which gives us 0. So we're left with 6y is equal to 60. Divide both sides by 6, and we get 10. So y is equal to 10. So our y-intercept is going to be 0, -10. So here we go. Let's look at this problem. If the point 5, 0 is on a graph, is 5, 0 the y-intercept of the graph? Explain. So I want you to think about this before you hear my answer, and I want you to come up with your answer and your explanation. So you might want to take a second and pause and think about this. Okay, so in this case, the y is 0. Since the y is 0, that means that we aren't moving up and down at all, so we're not on the x-axis. We're not moving, and I apologize, I wanted my pen. We're not moving up and down, we're moving left and right. So 5, 0 means I'm going to get here. So again, because this is a 0 for our y, we know that this is not our y-intercept, this is actually our x-intercept. So no, 5, 0 is the x-intercept because the y value is 0. And when the y value is 0 in an ordered pair. That tells us the x-intercept. All right. So now you have two your turn problems here where they want you to find the x and y intercepts. Make sure that you show all your work. And I also would like you to go on to the online book, and I would like you to plug in your answers on those your turns. Again, if the numbers are different on the online resource, change them in your book. All right, so now we're actually given a graph of situations. So in this case, we have the tramway and its distance from the peak. And we are going to we're going to find and interpret the x and y intercepts for each situation. So it's pretty easy to find them. Now, understanding what they mean is another point. So in this case, when you look at the graph, you know that your y-intercept in this case is right here. Your y-intercept is 0, 4,500. Okay, so what that means is at 4,500 meters, the tram has not moved at all. So it hasn't, and I don't want to say it hasn't moved at all because we're talking about time. So when it has not started its descent, the tram was at 4,500 meters. Our x-intercept is over here at halfway between 14 and 16, which is 15. So since it's 15, 0, what that tells me is it takes 15 minutes. Okay, so it takes 15 minutes for the tram to get down to 0 elevation, okay, or to reach the peak. And I'm sorry, this is to get to the top. So it takes 15 minutes for it to get to the top of the peak. All right, so let's take a look at this one. I like it better when we can actually work through it. So we have a hot air balloon that is 750 meters above the ground, and it begins to descend at a constant rate. Now, this constant rate is important. If it doesn't descend at a constant rate, that means that, or that doesn't tell us whether or not it's a line. Constant rate tells us that it's a line. Think of the constant of proportionality. The fact that it's constant tells us that the change is always the same, which is the same thing for this problem. So it has a constant rate of 25 meters per minute, and it's going down 25 meters per minute. So the function f of x equals 750 minus 25 times x represents the height of the hot air balloon after x minutes. So in 1 minute, it descends 25 meters. So if I put in 1 for x and do 750 minus 25, that tells me where it is after dropping down for 1 minute. All right, so now what I want to do is I want to find the x-intercept. So I'm going to replace f of x, because remember, f of x is our y in this case. So I'm going to replace f of x with 0. And I'm going to say, okay, 750 minus 25 times x will give us 0. So what value of x gives me a f of x or a y of 0? Okay, and when I go through and I solve that, so I'm going to subtract 750 from both sides, and then I'm going to divide both sides by negative 25, and I'm going to get 30. Okay, so what this tells me is that it takes 30 minutes to reach the ground while in that balloon. Okay, so now I know that we can just look at the graph and have it tell us that. So I'm also going to do that for the y-intercept. So here's our y-intercept, and that's at 750. So what I would do to solve those, I would replace my x with 0, and then I would solve for my f of x. In this case, what this tells us is the height above the ground when it starts is 750 meters. So before the balloon starts to descend, it's at 750 meters. And we could actually figure that out without reading this part here. So if I had actually taken this out, if I would have taken this out and looked at the title, the height of a hot air balloon, and height and time, I could have figured out, okay, at 0 minutes, So it starts, because 0 minutes is the start of something. So the starting height of the balloon was 750 meters. And then I can figure out that it took 30 minutes because my x-intercept is 30, and we know that 0 is ground level. So it took it 30 minutes to reach the ground. Now, a classmate says that the graph shows the path of the tram. Do you agree? Here's the hard part. In this one, they're not worried about the fact that, so it's telling you that it's a tramway, and it's traveling a distance of about 4,500 meters to the top of the peak. Okay, so even though here it says that it's going down, this is actually telling us that it's actually telling us that it's going up. So in this case, it's not telling us the path. It's only telling us the speed. All right, so here they have another your turn problem. Again, I want you to do what they have in the book or in the online book. If it doesn't match, do what's in the online book and change it in your notes. All right, and graphing linear equations using the intercepts. So this part, again, as long as you can plug in your zeros and find your numbers, this part is super easy. So I'm going to skip A, it's just an example for you, and we're going to do B. So we're going to write the equation in standard form. So we have 18y equals 12x plus 108. If I subtract 12x from both sides, I would get 18y minus 12x. So it would look like this. It would be 18y minus 12x. But we know that we want it to be addition. So we have to remember that we can change it. We can say minus a negative is like, or I'm sorry, minus a positive is like plus a negative. So that's how I'm going to change that. So that way I can rearrange it to negative 12x plus 18y. So now I want to find the x-intercept. So I'm going to replace the y with 0. When I do that, I'm left with negative 12x is equal to 108. If I divide both sides by 108, I get negative 9. Okay, so then I know that one of my points, so my x-intercept is going to be negative 9, 0. So what I can do is I can plot that. So negative 9 all the way back here. So this is negative 2, negative 4, negative 6, negative 8. So negative 9 is right about here, about halfway. So there's one point. Now, even though I don't know the slope or, anything like that, and I know we haven't talked about slope yet, but so even though I don't know the rate of change and to help me graph, I can use the y-intercept. So if I know 2 points on the graph, I can draw my line. And so you can always find 2 points by finding the x and the y. Intercepts, excuse me. So I have negative 12 times 0 because I want the y-intercept. So I replace the x with 0. And I'm left with 18y equals 108. And I divide both sides by 18 and I get 6. So my y-intercept is 0, negative 6. Or I'm sorry, 0, positive 6. So I'm at 0 and I go up 6. So now I have 2 points. And to finish this off, what I would do is I would draw a line through them. Okay, now this one doesn't give me a situation, so I can just assume, not a box, a line, sorry about that. I can assume that this goes on forever. I don't have to worry about it starting and stopping at certain points. Right? And again, it's a little bit easier for you guys to draw your lines because you have a ruler and pencils, and so there we go. That looks a little nicer. All right, so then now you have one last your turn where you have the equation given to you and you want to find the x and y intercepts. So yes, you need to have those answers. And then I would like you to graph the equation. Now it looks like here it already graphed it for you, which is interesting. So you might have gotten lucky on that one that they made a mistake. However, like I said before, I want you to go into the online resource and I would like you to please go in. If it's different in the online resource, change it in your book and answer it the way they have it online. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.